Homework help. You get homework help. Let's start. Happy to help you guys out. Thanks for tuning into my video. You know, I don't make them for fun. I don't make them because I love doing the same homework that you guys are doing. I make it for two reasons. So I can feel what you feel. Like, oh man, this homework was hard, Mr. Graham. But also so that you get a hand. You know? So you get a hand. It's not always easy. Let's get to it. You should be on page 110 and 111. It's more area models with division. You should see this. And this is another example. If you remember from last night's homework, you're taking the big number and you're putting it in the box for division. And then you're taking the number that we're dividing by, the number that we're putting in each box, and you're putting it on the side right there. Then your task becomes what times what can get me very close to that number. And look how big that number is, 2,120. Well, they start with big numbers in the beginning. And thanks to that, they can go easier and easier, smaller and smaller numbers as the problem goes on. And we want to kind of copy that strategy. We want to make it easy for us. Let's look at the questions they have for us on page 111 real fast. They want us to look at the problem on the back. I mean, not on the back, but on the page on page 110. How many full boxes can they ship? Well, if you look at the work they did here, their final answer is 531 with one remainder. The remainder is how much DVD players they have left over, and this represents how many full boxes they can make, and this is how many leftover DVDs they have. So when it asks you how many full boxes can they ship, that just means, well, what was the final answer? Can you find it? Yeah, it's right there. It's not hard to see. 531. What does the remainder mean in this problem? It means there's one DVD left. And you can see that on under all their subtraction. Right here, when they subtracted, when there's only one left, well, that's the remainder, because 4 can't go into 1. So there's one DVD player left. Did I put DVD? I meant DVD player. DVD player. If the factory could ship partially filled boxes, how would the answer change? So right now the factory is not allowed to ship a box unless it's full, which is why there's only 531. But what if they were allowed to put that one guy all by itself into its own box? How many boxes would there be then? How would the answer change? It's simple. It'd be one more box for that remainder. So it'd be 532 instead of 531. How is the partial quotients model on 110 like the subtracting partial products model on 108? So they're asking you to associate last night's homework with a new example. And the partial products model is very, very similar indeed. All you do is continue to multiply, subtract, multiply, subtract, multiply, subtract. And let's say that in both models, you need to continue to multiply and subtract. And that's a theme that you're going to have to get used to with division nowadays. Multiply, subtract, multiply, subtract. Which division model do you like better? Area models or subtracting partial products or finding partial quotients? Explain how that model helps you divide. If I had a choice, I'm gonna continue teaching you what seems to be the best way, you know, for fourth graders to wrap their minds around it, and what's connected the most to what we already know, and that is area models. We're gonna say area models are best. Remember the big stupid box thing from last? It's the same thing but for division. Area models are best. They help the most because they are the most visual, and they break up the problem into bite-sized pieces, little pieces. So we're going to continue to work with area models because that's my choice as your teacher, and I think that's what's best for you. If you disagree and you want to do things your own way, I won't stop you, but you better get everything correct. Okay, you better get the answer. If you start, getting everything wrong, doing it your own way, not my way, we're gonna have a problem. But if you just want to go, I'd rather just do what you're doing, Mr. Graham. Well, obviously, that's cool, and I recommend it. Doesn't mean you have to follow me like a slave or anything. You're not my slave, but I recommend it. What do I recommend exactly? Let me show you. 1,010 divided by 9. The area model would have you make a little box, put 1,010 inside, and 9 on the outside. You're going to subtract, so just get used to that. Now think to yourself, 9 times what can get me close to 1,000? You know what's a good place to start? Think about tens. Because 9 times 10 is 90, right? 9 times 10. That equals 90. But I don't know why I put it right there. I should put it right next to it. 9 times 10 equals 90. And that would be good if we were trying to get close to 100, but we're not trying to get close to 100. We're trying to get close to 1,000. So wouldn't it be okay to add a 0 to that, and then add a 0 to that, and then look how close we are to 1,010. We're super close. So 100 is actually a fantastic place to start. So you put 100 on top. 9 times 100 is 900. Because 9 times 1 is 9 with those other zeros added in. Now we got to do some subtraction, and we're going to need a new box. 0 minus 0 is 0. 1 minus 0 is 1. You can't do 0 minus 9. So we have to borrow and turn that 0 into a 10. And that 1 is gone now because it turned into a 0. 10 minus 9 is 1. And that's what we have left. So now we get to ask ourselves, how many times how close can we get to 110? Well, that's super easy too. I'm going to do 11 because I know that 9 times 11 is 99. And isn't that pretty close to 110? You don't have to do it like me exactly, but the closer you get to the number on top, the shorter the problem will be, the quicker you'll be done. So 0 minus 9 we can't do. So we better borrow, turning that 1 into a 0, and turning that 0 into a 10. 10 minus 9 is 1. 0 minus 9 can't be done either. So we better borrow from that 1 and turn him into a 10. That 1 has nothing left, so you know it's a 0 now. But 10 minus 9, that equals 1. That's how much we have left over. Now, are we all done? Well, to know that, you have to ask yourself, can 9 fit inside that number? If it's smaller, then yeah, 9 is smaller than 11. 9 can go in 11 one time. 9 times 1 is 9. And I think you can see that we're only going to have a little bit left. 11 minus 9 being 2. So now we got to add all of this up. 100 plus 11 is 111, plus 1 is 112. Here's a remainder. 112, remainder 2. If I did this on my calculator, calculators don't show you remainders. They show you decimals. But if I did this on the calculator, because I know my decimal conversions, it should give us 112.222222 whatever. So let's do 110 divided by 9, and hopefully it gives us 112.222. 110, or 1010 divided by 9 equals 112.222. So that means that we did do that right. Hooray! Not enough to get you comfortable with it yet? Watch me do it one more time. And please, really watch. Get used to the steps. You know, it's a pattern. It's the same thing every time. The first thing we're going to do is draw a little box. Actually, let's draw a fair-sized box so we're not like so crowded. Not too humongous, but, you know, big enough. Put the number that's being divided by, and the number that's getting divided, sorry, inside the box. Put the number that you're dividing by outside. The divisor and the dividend. Now ask yourselves, how many times can 6 go into 5,000? Wow, we're going to need a big number. You know, 1,000, think about that. That's 1,000. 6 times 1,000 is the same thing as 6 times 1 with some zeros at the end. And that gives you 6,000. That's too big. That's more than we need. But 1,000 is not so far off. So let's do, how about 900? 900. I also like 900 because 6 times 9, forget the zeros for a second. 6 times 9 is 54. And I see like a 57 right there with 2 more numbers behind it. So I know that the 9 is good. It's just that I need it to not be a 54. I need it to be a bigger number. So 6 times 900 helps a lot because you get to do 6 times 9, which is 54. And what about these two numbers? Well, we've got 2 zeros, so let's drop those zeros. And that's pretty close. That's pretty good. We're going to have to do some subtraction, though. So let's subtract. That's next. 3 minus 0 is 3. 8 minus 0 is 8. 7 minus 4 is 3. And 5 minus 5 is nothing. Now we have 383. I want you to practice thinking 6 times what would give me like 30-something. You know, like 30-something. Let's see, 6 times 6. 6 times 6 would give me 36, and that's really close to 38. But what about this 3 hanging out all by itself with nothing below it? No problem. Add a 0 up there, add a 0 down there. 6 times 60 is 360. Now go ahead and do some subtraction. 3 minus 0 is 3. 8 minus 6 is 2. 3 minus 3 is nothing. We're not done yet. Dang, I thought we'd be done, but not quite yet. Now we have 23 left over. Ooh, we can get close to 23. 6 times, well, not 4, because 6 times 4 is 24. It's too big. But 6 times 3, that's 18. 23 minus 18 is simple subtraction. You can use your fingers. 19, 20, 21, 22, 25. 5 is less than 6, so we can't divide anymore. So that's our remainder. So we got to add all this stuff up. We'll get 963 with the remainder of 5. Let's use a calculator to see how close we got. It should be 963 point something something. So 5783 divided by 6. 5783 divided by 6. 963. 963. That's a good job. All right, guys, that's all the time we have. We probably went a little long. I'll see you next time for homework. All right, bye.